Okay, now we're going to determine if we have some rational or irrational numbers after we've performed an operation. So let's get started with that. We have a root 12 plus 2. Now this ends up being approximately equal to 5.464101 So it continues forever. This little squiggly line here, or these little set of squiggles, just means approximately, which means not exactly equal to. In the same way that 2 plus 2 equals 4, it's exactly equal to 4. That is what that means, exactly equal. But this means approximately equal to. So it's not going to be equal to because we can't fit every single digit onto the screen. Right, so we know that there is no recurring pattern here, it continues forever, and that means that this is irrational. If we look at B, we have root 9 plus the square root of 16. Now, both of these are perfect squares, so we can actually perform the square root function on each one and get 3 plus 4, which is equal to 7. So this is rational. Okay, for part C, we have the square root of 5 minus the square root of 2. Neither of these are rational numbers, so we're essentially taking an irrational number away from another irrational number. And what we end up with, if we put this into our calculator, is 0.82185445151, and it continues onwards. And we can't see any clear pattern here, so it's a non-terminating, non-recurring decimal number, and that means it's irrational. Okay, here's a couple for you guys to practice, so just give the video a pause, give them a go, and then I'll solve them. Okay, let's get started. So for D, we have 4/5 being multiplied by root 3. And this, we can perform this operation and get 4 times root 3 over 5, or 4 root 3 over 5. Now ultimately, when we solve this particular division problem, we'll end up with 1.385540646, and it will continue forever. But we can also see that this particular number couldn't be expressed as the fraction of 2 integers, and so we should know, because of that, where the denominator is not 0, because of that it is going to be irrational. Okay, looking at E, we have root 10 divided by 2. Again, this is the same as a fraction where the square root of 10 is divided by 2. I can't make this fraction into a fraction of 2 positive or 2 integers. Even if I was to multiply both the numerator and the denominator by root 10, I would still end up with an irrational number in the denominator. So we can't really get rid of that, and that's making this irrational. Alright, let's look at F. So for F, we have the square root of 49 divided by the square root of 7. Now, if I were to make this into an equivalent fraction by multiplying the top and the bottom by root 7, it would be equal to 7 root 7 over 7. We could cancel both of the 7's and we'd still end up with the square root of 7, which is an irrational number. It's very easy to make some kinds of mistakes in these particular questions because ultimately we might have two values that are multiples of each other, and your brain might think, oh, or square roots of each other, and we might think, let's just square both parts of the fraction, but that doesn't create an equivalent fraction. So the actual result here is irrational. Alright, that's it for this video. Hopefully it's helpful, and I will see you in the next one.